Hello everyone and welcome back again to EduNext Academy. So in the previous classes we have discussed many things about polynomial, but today we will discuss about a new thing, that is factor theorem. So let us start with factor theorem. So what is that? What is a factor theorem? That is a very important concept in polynomial. So factor's theorem states that for a polynomial, here f of x is a polynomial, the binomial x of a. Here x of a is a binomial. It contains two terms, that is a variable x and a constant a is a factor of f of x. So this binomial is a factor of f of x if and only if and only this is a very important condition which has to satisfy to become a factor of a polynomial. So if and only if f of a is equal to 0. Means, for example, here select p of a, that means a binomial, is equal to x minus a. Here, sorry, f of a is a binomial which is x minus a. So we have to satisfy according to this equation, this x of x minus a should be equal to 0. Then x is equal to a. We have to put, if we have to put this value of x of a in the polynomial f of x, then if the result came 0, that means it is a factor of f of x. That means f of a is a factor of f of x. Now let us solve an example to see whether this particular binomial is a factor of this particular polynomial. So here the question is given, find the remainder when this polynomial x cube plus 3x square plus 3x plus 1 is divided by x plus 1. We have to find the remainder. How we will find the remainder? So here f of a is equal to x plus 1. So according to this factor theorem, we have to make it equal to 0. That means this x is equal to minus 1. Then we have to put this value in the polynomial f of x. Means minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. How much it is coming? Minus x cube means minus 1. Minus x cube means minus 1. 3 into minus 1 square, that is plus 3. Minus 3 plus 1. Now you see here, minus 1 plus 1 cancels. 3 minus 3 cancels, the result is 0. So yes, x minus 1 is completely divisible. That means x cube plus 3x square plus 3x plus 1 is completely divisible by this term or binomial x plus 1. And it proves that x plus 1 is a factor of this particular polynomial s cube plus 3x square plus 3x plus 1. Let us solve another example of your exercise 2.4 NCERT test 9 class textbook exercise 2.4 through R. Here given f of x is equal to x cube plus 3x square plus 3x plus 1. And the binomial is given x minus 1 by 2. We have to check that this is a factor, this particular binomial is a factor of the polynomial f of x. Now, similarly, the previous problem, we have to solve this problem. So let us solve this. So let f of a is equal to 0. This implies x minus 1 by 2 is equal to 0. This implies x is equal to 1 by 2. Now let us put in this value in the above equation or above polynomial. What about f of 1 by 2 is equal to 1 by 2 cube plus 3 into 1 by 2 square plus 3 into 1 by 2 plus 1. What is the final value it is coming? It means 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. Now the total LCM is 8, 1 plus 6 plus 12 plus 1, that is equal to 1 plus 6 plus 12 plus 8 divided by 8, which is not equal to 0. That means this particular x is equal to 1 by 2 or the binomial f is not a factor of this particular binomial. This is another question from your exercise 2.4, that is 3i. You are given the binomial x is equal to 0. This is not a binomial, this is a monomial, and we have to check whether this particular value is factor of this polynomial. So how does one this? Very simple. So let f of x is equal to 3x square x cube plus 3x square plus 3x plus 1, and f of a is equal to 0. That means x is equal to 0. Now let us put this value in the polynomial. We got 3 into 0 cube plus 3 into 0 square plus 3 into 0 plus 1. The answer is 1. It is not 0. So this particular monomial is not a factor of f of x. Again, let us solve another example. This IB. The f of a given x plus 5. We have to check whether this x plus 5 is a factor of this particular polynomial. So here f of a, according to factor theorem, we have to make it 0. This implies x plus 5 is equal to 0. This implies x is equal to minus 5. So we have to put this value in the above polynomial. That means 3 into minus 5 cube plus 3 into minus 5 square plus 3 into minus 5 plus 1. It has some value which is not equal to 0. This particular value is not equal to 0. It has some value, whether positive or negative, but it has some value. So this f of a, that is x plus 5, is not a factor of this particular polynomial f of x is equal to 3x cube plus 3x square plus 3x plus 1. Now let us do another problem from your exercise 2.4. In question given that by using the factor theorem to determine whether the gx is a factor of f of x. That means p of x. So p of x is a polynomial here, and we have to check whether g of x is a factor of polynomial p of x. Given that p of x is equal to 2x cube plus x square minus 2x minus 1, and g of x is equal to x plus 1. How? In the same way we have to check. That is, we have to make it gx is equal to 0. That means x plus 1 is equal to 0. This implies x is equal to minus 1. So 0 of gx is equal to minus 1. Now let us put this value here in the above polynomial. We come to 2 into minus 1 cube plus x square means minus 1 square minus 2 into minus 1 and minus 1. What is the value? So here minus 2, this is plus 1, this is minus and minus 2 plus 2, minus 1. Now see, minus 2 cross 2 cancel. 1 minus 1 cancel. That means the final result is 0. So here it is proved that g of x is a factor of p of x. Now let us solve another question number 3 from your exercise 2.4. It is an interesting question, so we have to find a value of k. So question given here, find the value of k if x minus 1 is a factor of px, where px is x square plus x plus k. So how to solve this? So let p of a is a factor of p of x. So here p of a is given that x minus 1. According to Factor's theorem, we have to get to 0. That means 0 according to Factor's theorem. That means x is equal to 1. Now let us put this value of x in the polynomial, ever polynomial. Means 1 square plus 1 plus k must be equal to 0 according to Factor theorem. So that is x plus 2 is equal to 0. This implies the value of k is equal to minus 2 here. This is another interesting question from your exercise 2.4. Your question is that find the remainder when this particular polynomial is completely or divided by the x minus a. That means you know that x cube minus a x square plus 6s minus a. If you divide this particular binomial, then we have to, some remainder will be there and we have to find out that remainder. So how to solve? Similarly, according to Factor's theorem, we have to make this particular value x minus a equal to 0. You understand or not? Understand? Okay. So now let p of a, p of x is equal to 0. P of a. That means x minus a is equal to 0. You understand? You have to remember that the factors p of a must be equal to 0 according to Factor's theorem. You have to remember that statement. So this implies x is equal to, your minus sign that will go to outside, another side, right hand side becomes plus 1. So x is plus 1, a here. So now let us put this value x is equal to a in the above polynomial. That means in place of x we have to put a. So a cube minus a into a square plus 6 into a minus a is equal to 0. Now this is a cube, this is also a cube. This is 6a, that is a cube minus a cube plus 6a minus a is equal to 0. That is not equal to 0. So that is 5a. So 5a is the answer. 5a is here, the remainder. After dividing this polynomial by this binomial x minus a. So this is the remainder. You understand? I hope you understand.